Hi, this is Srirag Ramadegu. In this video, we are going to learn about confusion matrix and some of the matrices used in this. And we'll take an example and we'll go through using confusion matrix using Python. So, before knowing what is a confusion matrix, let us take an example. Here we have both actual score and predictor score. So say this is a classification model, and when someone asks us what do you think about this model, the first thing that we look at is accuracy. So you know for for this values, the accuracy is around 60%. So the misclassification rate or the error rate is 40%. Now the question is taking accuracy as an evaluation matrix is a good idea. We'll take an example where we have around 100 events, and 99 of these events are from class A, and the one event is from class B, and we are supposed to classify this. So I don't even need a classification model for this. I'll just write a program to print the result as a class A for any input given. So this will give an accuracy of about 99%. So is this a good idea to take accuracy as an evaluation matrix? No. To overcome this limitation, we are going to use confusion matrix. So here we can see in the x-axis we have the actual values, and the y-axis we have predicted values. So I took two classes. In this instance I took positive and negative as my two different classes, and we can see here if the observation is positive and the prediction is also positive, then it is called true positive. And if the observation is positive and the prediction is negative, it is called false positive. False positive is also called as type 1 error, and when our observation is negative and prediction is positive, it is called false negative. And false negative is also called as type 2 error in statistics. So when our observation is negative and prediction is also negative, then it is called as true negative. So this is our confusion matrix, and there are some matrices that we can get from these confusion matrix. So first, it's accuracy. So as we discussed about accuracy before, it is out of all the classes, how many events did we predict correctly. When we write a formula about it, it's total correct predictions by total predictions into 100. So in terms of confusion matrix, it's true positive plus true negative by total predictions, that is true positive, true negative, false positive and false negative. So as it is percentage basis, I multiplied it by 100. Now coming to recall. So out of all the positive classes, how many events did we predict correctly? This is what recall tells us. In any case, recall should be as high as possible, and the formula for it is true positives by true positive plus false negative. As per the definition itself, we can say that. Now coming to precision, out of all the positive classes that we predicted correctly, how many events are positive? That's what precision tells us. High precision implies small number of false positives. So the formula for precision is true positive by true positive plus false positive. And so when it comes to a problem, we try to know in combine how good is a model based on the both precision and recall. And if we would like to compare these two things, we are supposed to use F measure, or sometimes called as F score. So we use this to measure recall and precision at the same time, so in order to compare them. And this takes a harmonic mean of recall and precision, the formula itself. So F score is 2 times recall and precision by recall plus precision. Now let us take an example and try to show this confusion matrix using Python. Here, in order to generate confusion matrix, I'll first import modules from sklearn library. So first I'll import confusion matrix module from sklearn.matrix. And for the accuracy, I'll import accuracy score from sklearn itself. Now I'll take some actual values. So as we have seen in the PPT example, so say I'll take a list of values 1 0 1 and the predicted values. See, the predicted values can be, so we can take result is equal to confusion matrix of actual score and predicted score. We run this. Now let's see the result. So here's our confusion matrix. So we can see there are only two values here. These two ones are predicted as zeros. So from confusion matrix we can see that all the zeros are predicted correctly and there are no false positives here. At the same time, there are two ones that are predicted as zeros here and there are other three ones that are predicted correctly. So now let's see what the accuracy is. Obviously it should be 80%. So 0.8, it's 80%. And we can even know the values of recall, precision and F-scores. Actually we can have a complete report of that. First I'll try to import classification report from sklearn. Here from the result report we can say that we can see the precision is 71% for 0. That means out of all the correct predictions, 71% are those of the 0 class and 100% are those of 1 class. And we can see the recall for 0 class is 100% and for 1 is 60%. And so far we have gone through an example for discrete values. So what happens if our model has continuous values, say like p equal to, we have values like for 1 say 0.8. so here's the continuous values that are predicted. And now obviously we can't take the above analysis here because all the accuracy and precision all are going to be zeros here because they are not going to be equal to the actual values but are close by. So what are we supposed to do in this kind of situations? Here we can keep a threshold value like say for instance I'll take a threshold value as 0.5. Now so all the values that are above 0.5 are set to be 1, and 0.5 and less than 0.5 are set to be 0. So say if I can replace those values, I'll take an empty list first. If x is greater than 0.5, then 1, else 0, and let's print L. So we just converted them to discrete values, and let's see how is this going to affect our result. I'll take classification report itself and hit run. So here we can see on an average the precision is around 0.71 and recall is 0.70 and F score is 0.7, so which did not make as much progress as a previous model. So we can try to change the threshold values and check the F1 score, the accuracy and all, and try to see which is the best threshold value that could have the make the model have high precision values. And in this regard I'll try to introduce ROC curve here. This ROC curve is commonly used graph that summarizes the performance of the classifier over all possible threshold values. So it is generally generated by plotting the true positive rates against the false positive rates. So using this ROC curves we can see if for all the possible threshold values how is the model performing, and thereby we can stick to the perfect threshold values. So this is all regarding the confusion matrix. Thank you.